On June 16, 2026, a team of geologists walked into Biscuit Basin in Yellowstone National Park. They had been there 2 days before. They had walked the same ground, taken measurements, marked coordinates. They knew exactly what the landscape looked like. What they found when they returned wasn't possible, not by any reasonable expectation. Where solid ground had been, ground they had stood on with their own boots, there was now a pool of gray, boiling water. No explosion debris around it. No warning, no crater ring, just a hole in the earth that hadn't existed 48 hours earlier, filled with superheated water reaching nearly 200 degrees Fahrenheit, thumping and roiling like something alive beneath the surface. And here's the part that no headline fully captured. This was the same basin that exploded in July 2024, sending mud and boulders 600 feet into the air while visitors ran for their lives. The same area, the same pool, and for the second time in under 2 years, the ground beneath Biscuit Basin had torn itself open. This time, in silence, overnight, while nobody was watching. What is happening beneath Yellowstone right now is not what most people think. And what scientists found in those 48 missing hours is something they have never had the instruments to study before. Yellowstone National Park sits above one of the most geologically violent systems on Earth. Most people think of the supervolcano, the caldera capable of continent-scale eruptions. That threat is real. But scientists will tell you honestly that the supervolcano is not what concerns them most on a day-to-day basis. The more immediate threat lives at the surface, a vast, interconnected system of boiling water, pressurized steam, and chemically altered rock sitting just a few dozen feet beneath the ground that 4 million people walk across every single year. This system feeds the geysers and hot springs that make Yellowstone famous. And without warning, without any reliable precursor signal, it sometimes explodes. Hydrothermal explosions are Yellowstone's most common violent hazard. They happen somewhere in the park every year, usually in backcountry, where no monitoring equipment exists and no humans are present. When they occur near boardwalks and visitor areas, the consequences depend entirely on timing and direction. Biscuit Basin is not backcountry. It is a front country thermal area less than 2 miles northwest of Old Faithful. Before July 2024, it had a boardwalk that brought people within arm's reach of Black Diamond Pool. The pool that, on the morning of July 23rd, sent rocks and boiling debris 600 feet into the sky while hundreds of visitors ran. They made it by the narrowest possible margin. The boardwalk was destroyed. The basin was closed. Scientists installed cameras, seismometers, and infrasound detectors. They vowed to understand what they had missed. They never fully reopened the basin. 18 months later, the ground proved that decision correct. June 13th, 2026, 5 hours and 9 minutes past midnight. Monitoring equipment at Biscuit Basin registered something. A low-frequency acoustic signal called infrasound coming from the direction of Black Diamond Pool. This was exactly the signal the new monitoring station, installed just 328 feet away in summer 2025, had been built to detect. Scientists had hoped it might someday catch a warning before an explosion happened. The data showed the explosion had already occurred. 3 separate vents had opened simultaneously in the dark, driven by superheated water finding new pathways to the surface. The water converted to steam the instant pressure dropped. That conversion is not gradual. It is instantaneous, violent, and the force of it split the earth open. One fissure ran 61 feet long, up to 5 feet wide, filled with water at 194 degrees Fahrenheit. By the time park staff noticed the Firehole River running milky gray for nearly 4 miles downstream, the explosion was already over. The ground had broken open in the dark, and the first visible sign was a river the color of ash. When geologists reached the site the next morning, they mapped 3 vent groups, cataloged the cracked earth, measured temperatures. They marked where they had walked, and they left. They came back on June 16th. The pool wasn't there on Sunday. By Tuesday morning, it was. A roughly 21 by 17-foot basin of gray, silty, vigorously boiling water had formed in the 48 hours the team was absent, right where they had stood. The ground hadn't erupted to form it. No debris ring, no ejected rock, no crater from above. It had formed by collapse. The earth beneath that spot had given way, opening a direct connection to the hydrothermal system below. The thumping was the first thing the team heard when they approached. A heavy, repetitive percussion, steam bubbles forming and collapsing within the pool, a sound that startled even scientists who had spent years studying Yellowstone's thermal features. On June 18th, the pool began erupting, spouts of near-boiling water reaching 20 to 30 feet into the air, then settling back into churning gray motion. It erupted again on June 23rd. No precursor, no pattern. The USGS called this an unprecedented scientific opportunity, not because of scale, but because no hydrothermal explosion had ever occurred this close to active instrumentation. For the first time, scientists may hold data from the moments before, during, and after an explosion at close range. That data could change everything about how these events are understood, because right now, there is no reliable method to predict them. Here is what a hydrothermal explosion actually is, and why it requires no help from the supervolcano to kill you. Deep beneath Yellowstone, water percolates through fractured rock, absorbs heat rising from the magma chamber miles below, and begins to ascend. As it rises, pressure drops. At a critical threshold, usually within the top 50 to 150 feet of the surface, the water reaches a point where liquid can no longer exist. It flashes instantaneously to steam. The volumetric expansion is catastrophic. Water becoming steam expands by a factor of roughly 1,600. When that happens underground, constrained by rock and soil, the force goes upward. Think of a sealed pressure cooker. Now imagine the lid isn't a lid. It's 30 feet of rock and soil. And imagine the pressure inside builds not over minutes, but over years, as silica deposits slowly seal the underground conduit system. The same mineral that builds Yellowstone's famous geyserite formations can plug the pathways that allow safe pressure release. When conduits seal, pressure builds. Eventually, something gives. Not from the magma, not from any volcanic process, just from water, heat, and a sealed pipe. The 2024 explosion launched 1,500 rocks from Black Diamond Pool. None of the bedrock, 175 feet down, was disturbed. The entire event happened within the top few dozen feet of Earth. That is simultaneously less catastrophic than a volcanic eruption and far more unpredictable. Hydrothermal explosions leave no magmatic fingerprint. They provide no reliable warning, and Yellowstone produces more of them than any other place on Earth. Mary Bay, on the northern shore of Yellowstone Lake, is the world's largest known hydrothermal explosion crater, 1.7 miles across, produced in a single event 13,000 years ago. Events at that scale are rare. Events at the scale of Biscuit Basin, capable of destroying whatever is directly above them with no warning, are not. 4 million people visit Yellowstone each year. On the morning of the 2024 explosion, 209 visitors had entered Biscuit Basin by 9 a.m. The explosion occurred at 10. If the blast had directed itself toward the crowd instead of toward the Firehole River, those visitors would have been inside a debris field of 100-pound boulders moving at ballistic velocity, launched from a pool they were standing 6 feet from. The geologists who returned on June 16th to find a boiling pool had walked that exact ground 48 hours earlier. If the collapse had occurred one day sooner, they would have been standing on the Earth as it opened. The basin remains closed. Scientists say the current volcanic alert level is normal, that the supervolcano shows no unusual signs, that the caldera is stable, that June 2026 is consistent with Yellowstone's baseline hydrothermal behavior. What they are also saying, precisely and without ambiguity, is that baseline hydrothermal behavior at Yellowstone includes explosions that occur without warning in areas where visitors walk in the same basin twice in under 2 years. That is not reassurance. That is the honest shape of the hazard. In the weeks since June 13th, temporary monitoring stations have been placed inside Biscuit Basin. Scientists are analyzing the infrasound and seismic data captured from the moment of explosion and the hours that surrounded it. They are looking for something no one has found before: a specific acoustic or seismic signature that might precede a hydrothermal explosion by minutes or hours or days. No hydrothermal explosion in Yellowstone's monitoring history has ever been predicted before it happened. But the June 13th event occurred closer to active instrumentation than any explosion on record. If there is a warning signal, if the Earth gives some measurable indication before it decides to open, Yellowstone scientists now have their best chance of finding it. The pool is still there. It is still boiling. It is still erupting, without pattern, without precursor. Somewhere in the data from a station 328 feet away, captured at 5:09 a.m. on June 13th, there may be a signal that no scientist has ever read before. Whether they can decode it in time for the next one is the question that will define how millions of visitors are protected or warned in the years ahead. Subscribe to stay ahead of what's coming.